All right, here is the speed run of Project Saturn, the Excel Esports case from Harry Gross. Very fun case. We're going to start with this level 1, right? So I'm going to give this a named range so I could start to manipulate it. There's the notebook says to start with cell A1, right? So this is going to be my level 1 solution. So to use my address lookup on board, going to start with A1. And it says, oh, you need to look in X43. So, all right, well, X43, there, cell live. I got so confused because I was looking for, the var named range, right? But that didn't work. It is the cell with the text var in it. Which the easiest way to find it is just this, right? Match entire cell contents AS24. Then the cell below that, right, is this one. So I'm going to bring this over to my solution here. 43rd text cell in the 82nd column. So choose columns board 82. And then filter that based on is text of this thing, right? So there is the text ones, and then I need the 43rd of that, so index 43. Column BR, the row with that sum, right? So by row board sum is this, and then xmatch 28014 on that is the row number, right? So now it's just, address lookup of the board BR20. I got to find the cell with that contents. Can't use find and replace for this one because of the wildcard. So instead, I'm going to do toCall of the board. Then I'm going to do exact of that and the string I'm looking for to see where that is. Then I'm going to xmatch true on all this. So that's the cell number. I want the one directly above it, which means I have to subtract the number of rows to get the cell directly above it. And then it is, the index of toCall board by this number is the cell that I want. So there is the code, and then it says also to proceed to BF51. BF51 like that. So there's the code for the next one, and then I'm going to make myself an answer sheet. So this is level 1. The answer is 21574, 21574, boom. All right, now we're going to do level 2, and it just told us the code is serum. You can rotate this like this. I had no idea this was possible. Brute force this live. 1, 2, 3, 4 stripes times 4 legs is 16. So these, then it is filter this by this being greater than 0, right? Then it's the ceiling of the average of all this. It says the first one's 45, which matches. So hopefully this is right. We'll see. It's level 2. Level 3, level 2 has the code, right? 1221. 1221. So now we gotta split these apart, right? Which is just the mid of the sequence of the length of the C39 over 2. That's the length. It starts at 1 and steps by 2, and then the mid thing has 2 each time, and then it's, well, I'm getting it from C39, right? So this should be the formula, but it's in invisible text. There it is. So now I just XLOOKUP those on here, returning here, keeping that locked and lined up correctly. Those are the numbers, and then we add them up to get the answers. First one's 34, which it is. Okay, so there's the answers to level 3. Level 4, we should have, what's our code? WC 2024. WC 2024. All right, so we got to rotate this thing. I got to rotate the addresses is actually what I care about here. So I'm just going to make another version of this where I've got the addresses in here. So equals address of the row and the column, style 4 to get the relative with no dollar signs. So now in this, I'll just call this addresses. So now back here at different times, right? So sequence 20 rows starting at 0. So at different times, what does it look like? Well, it starts with just save array. And save array is like a lambda that just uses text join. It's just all it is. Of the addresses, right? So that's there. Now I'm going to use a more complicated lambda, right? So I load array first of all, right? So there's the array again, and now I'm going to rotate it because I've got to rotate lambda already. So I rotate that array by the direction arrow CW is clockwise. All right, so that can do flips and rotates and things. And then I save array to finish it. If you want to download or see my lambdas, check it out at the bottom. I don't know why it wanted to go everywhere. Save array just once. Yes, please. Thank you. All right, so that's them. All right, so now we start on here. How much time is it going to take to reach an M, right? So we do an arrow trip is another lambda on this range locked starting at here with the direction being arrow down, right? Arrow D is arrow down, and then the stopper is the M's. So it goes until it reaches the M. And then the time is the time going through the blank ones, right? So it's rows of this minus 1 is the amount of time it takes, right? So the start index, right? I gotta account for this row of spacing and these columns of spacing. There's 16 columns of spacing and 1 row, right? So the start index is ref to RC. So I take this and turn it into the row and column, right, as a row. But then I've got to subtract 1 row and 16 columns like that. And then the end index is after this falls by 2, right? So the row number gets 2 bigger because it falls by that much time, and then the column stays the same because it's just falling straight down in the same column, right? So the end index, right? So it starts at 14.2 of this, and then it ends at 16.2 of this, right? That's what this is, but it's rotating as we go. The addresses are rotating. So what is the board state, right? Is XLOOKUP the time on the time, returning on the state of the board. And then the answer is the index of the load array of the board by that row and that column. All right, is this all got good locks in it? Yeah, I think so. So now that should apply to all of them. And then actually the answer to this is just the row number, right? So it's only numbers of this. All right, so take this and we put it in answers for level 4. And we're ready to do level 5, right, which is the sum of all the answers so far. So now we'll see if everything so far is right. So now we got to play a array game here. This is like a graph theory question to see if these graphs are possible, right? So I text split. Well, I'm going to make a what if table. So the team and the lineup is here. So team A first, and the lineup is XLOOKUP of this on here, returning here. So then the lineup is text split of this by here. All right, so the way to solve this is you knock off the first person and subtract that many ones, right? And if that works, then good. If there's nothing left, if you end up negative, then it's not a legal graph and somebody's lying. Right, so the difference here is I need to go based on the position, right? So the position, there's up to 10 possible positions because one of these teams has 10. So if the position, always in S, is less than or equal to the first person in the lineup, always locked at 25, then -1, otherwise 0, right? That's what I'm going to do this, right? So if S32, this has got to be numbers, right? Like that, good. And the lineups have got to be sorted also, or else this doesn't work, right? So we sort the lineup in descending order. So now the new lineup is, forget about the first person. So it's everybody except the first person plus these differences here, right? This is that, and then it's sorted descending still. And this is already illegal, right? I've already got a negative here, so I know these people are lying. So this is the minimum of the lineup, right? Is the minimum of this. And if this ever ends up with a negative, then I know these people are lying. And I have to iterate on this a few times. Every time I just, I cut out the first person and then subtract that many. And then if the minimum of this is less than 0, then that means they're lying. So give me the team name, because I only want the liars, otherwise nothing. All right, so then that's the answer, just equals that. And now I do my data table here is data table based on this. All right, I'm getting some errors here, which I don't like. The lineup, what is this happening? Jeez. Can't change part. I know, I don't want it to be an array. I don't understand why this is an array. Okay, so equals text split of this by this thing, right? And that times 1 is, I think that's it, right? So concatenate the answers here. And let's see if this is right. And now I got to pull just the text because of all the thingies. Paste values, copy, paste. There we go. Okay, so now if we go from these going to go in random order, right? So if we end, so who goes before dim? So if the HP before dim is 119, right? Because it is above or equal to 100 to below 100, right? So if it was 119, it would go to 99, which is death. So if it's 100, it would go from 100 to 80, which is also death, right? Yeah, and that's it. So if HP is that, then we all die. Also, I appreciate the shout out here for my AI brain. If so if we starting HP is 211, right? So if damage is 211 minus 119 and 211 minus 100. So if so we're going to put the Titans in random order, and then however many come before dim, if they do between 92 and 111 damage, then we all die. So if damage is between 92 and 111, then we're in big trouble. All right, so this is the criteria that we die. So the question is, how many people go before dim? How many Titans go before dim? And that could be anywhere from 0 to 19. There's an equal chance of each of these, right? Because it's random, so dim could be anywhere. If there are, then what is the damage, right? So now selections, which is my permutations combinations, right? So and this is going to be a what if table, right? So like, let's say before dim is 10, because that'll give me the maximum number of rows at least. So selections of sequence 19, right? The other Titans are 1 to 19, and we're selecting 10 of them that went before dim, right? And the order does not matter. All right, so this is all the different possibilities. I have to leave room for more of these, right? But then this is the total damage is, by row of this. The sum is the damage, and then do we die? Well, if and this is greater than or equal to 92, and if it is less than or equal to 111, then yes, we die, otherwise we don't die. So how many of these possibilities do we die in, right? Is the sum of this. And now I got to figure out all these other ones, right? So I do my what if analysis, data table based on this. And this is going to take a second, but not ridiculously long, hopefully. Because, yeah, this is taking all the Titans that go before dim and seeing how much damage they do. And each of these has an equal chance of happening. Even though there's a lot more possibilities for some than others, there's an equal chance that dim is going to be in each position. So I'm going to end up equaling these at the end, right? So this, I don't know why that's an A, but it's supposed to be 0. This is just 0. And then the denominator here, right, is just the combinations. How many combinations out of 19 is this chosen? Right? That's the number of rows of this thing, right? Which I could have counted the other way, but I didn't. So now, what is the death possibility? Equals this divided by this. And then the average of these is the overall, the even average of these, right? Because their equal possibility is 9.84%. Equals this times 1,000, no, times 10,000 is 984. So I enter 984 to get the epilogue here. My Eric Ashton's AI is successful. Yay, the world is saved. But we have to clean up a lot of Titan blood. And we got to do bonuses. There's a hidden image here. I had no idea you could put hidden images in Excel, but you can. I learned today. Thank you, Harry. Selection pane. Ta-da! Show all, and there it is. I am colorblind. I have no idea what color this is, but as we know, if we're following our accessibility guidelines, we use the alt text. The dog has red hair. Answer is red. How many screws are in this thing? Well, you know, looks like 1, 2, 3, 4, 5, 6, 7, 8. 8 screws. Um, 5 different elements that can go in any order is 5 to the 5 times 5 factorial. Got that wrong live, which I'm a little embarrassed about. I forgot to do the factorial order. And then the last one is the cryptanalysis with no key. All right, this is going to be fun. So this here, and this is like, you can see the formula here, right? This is the Vignere cipher formula. We're just adding the Unicodes, like in the whodunit case, for example. All right, so string to array of this just is all the characters, right? So there's our ciphertext. The Unicode numbers are here. I'm going to say, what if the plain text was 32 every time, 32 being the space? So every time that's right, this is going to give me like an anagram of the key. If the plain text is a space, otherwise it's going to be nonsense. And this is unicare, right? So now if I do the frequency table of this, right, I see there's 45 A's and 31 N's, which is super suspicious, right? These capital letters, right? All the other keys are capital letters. So I'm just pulling out the capital letters. A, N, R, S, E, L, and B are the only ones in double digits. And with all these A's and N's, all right, knowing the Harry Gross extended universe, my first guess is going to be Lana, which is not right. My second guess, what has a lot of A's and N's in it? How about banana? All right, ooh, look at what we got here. AI, something. So I got part of the key right. So part of it is banana. All right. Other than banana, what's left? RSEL. All right. So now I'm just playing an anagram game, right? Bananas rule is the answer. I will leave the truth, if you want to know the truth of the origin of the Titan serum, how it got out, check that out. But that, I'm stopping the timer because I'm done. That is the answer to the last bonus, is bananas rule. All right, that's it for today. Thanks, bye. Thank you, Harry, for a fun case. All right, here is live attempt of Harry number 3. Save the world and look good doing it in this groundbreaking case from Harry Gross. 40 minutes, 10 minutes of reading, and 30 minutes of solving. Okay. 6 levels for bonus questions. Use Excel on your phone. Okay, well, I should get my phone then. Hold on. Okay, well, I mean, I do have Excel on my phone. We'll see if it is any use in this. Download the case now. 10 minutes of reading is a lot of reading. 6 levels, 4 bonus questions. That is less than usual, but more time than usual. Download the case now. The password to open it will be provided when you start. Okay, fine. So I haven't started yet, but I'm going to download. Project Saturn. So I put this in. It should ask me for the password, right? Yep. And then that will start my timer when I say, give me the password. So here we go. All right, Cassini 1997. Right, and did not work the way I was hoping, but I guess that's not a super surprise. Handbook, oh my gosh, geez. It's like a whole board game, I feel like we got here. I don't know if there's anything I could do to make my level stuff actually work here. Intro and bonuses. I mean, there's no like, it's not in the normal format at all, right? Yeah, okay, that's fine. We're just gonna make do with what we have. So let's see here. Case, yeah, this is the case, right? It's asking for a encryption code. I may have to go to the original one. I don't know what my thing did to this. So I'm gonna start with Project Harry. Enter the password. This file should not be open. And I'm gonna just like move in my template here. So if I do this and I just like move or copy my prep into there, that will bring in my lambdas. At least we'll see if I need subs. I'll go back. This I'm going to close for now. All right, intro, world falling apart. You're the only one with power to save. You don't have much time. Countless lives. Start by stumbling. See what into what seems like this is like Project Hail Mary. If you want to like your best, solve bonuses along the way. Hidden image of a very stylish look on the tab is the hair color red, blue, rainbow, black, or blonde. I think I only got out prize centers already. It can exalt us. There's such foods. I can't share the details with you yet, so I'll start by fixing the neural PCB A1 should guide you from there. Felicia kids, I love you. I'm sorry, I love you all. Oh my God, did he blow his braids out? This is dark, dude. Okay. Diagnostic analysis 1 error detected system exception cell X43 X43. VAR cell is compromised by the cell underneath it. Okay, so is VAR named range? Oh, it's compromised by the cell underneath it, which is AC31. So what am I looking for? Neural PCB 11. Enter the numbers used for the repair. Start by fixing neural PCB A1 should guide you. System exception, cell X43. It's like a little bit of a scavenger hunt. VAR cell is compromised by the cell underneath it, which is AC31. So let's see, if I'm in VAR here and then the cell below it is here, what if I delete the cell below it? Does that do anything? No. Because it's compromised by the cell below it. System.exception in cell X43. I mean, that did not seem to change anything. Variable name is too complex. Power overload. I mean, some of these say what to do. But this, I don't understand how this moves you on, right? Because VAR cell is compromised by the cell underneath it. The VAR is here. And then what am I looking for here? An image of a very stylish look under the tab is a hair color. I don't see how there's a hidden image unless it's in like the hidden parts. See what happens if I open up the hidden parts. Like this. And then what if I go to the last cell? No, that's the last cell, so there's nothing after that. I don't see what the hair color is. Declare no static members on generic types. Power overload in 43rd text cell in 82nd column. 82nd column, 43rd text cell. So for this then, otherwise 0, otherwise 1. Are the text cells. So this is going to be the 43rd text cell. If I do the cumulative total of the text cells, solder leak in column BR in row with the sum of 28014. So if I do the one that is 28014, if this scavenger hunt goes somewhere. 28014 is there, but what it said, I forgot what thing it was, right? BR, 28014 BR. 014. And then BR is here. Solder leak detected. Apply override and cell with the contents blank. Take care in navigation. Use web search if must. Oh, geez. All right, yeah, because that's those are wildcards, right? So to find the one with the content star star star, if you can use exact for that, it will probably work. Let's see what happens if I use exact. Exact star 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 is a string, and then this A1. Now I need to find the true in here. If that, then here, otherwise nothing. So there is the cell AD47. So AD, what was that? AD47, yeah. Yeah, I know it's star star star, but then what do I do with that? So on the one that says use web search if must, I'm like nowhere on this. Apply override. So AD41, I have to apply an override to AD41. No, AD, not AD41, the one with star star star. AD47. Override? Yeah, damn, this is like going nowhere. All right. Ankle joint. A giant metal object sits around a machine's console faucet asks for a password. Enter the decryption code. System arc day D6. Right, okay. That's that does not do anything. Decryption code, is that on the PCB somewhere? Joint decryption code is serum. Okay, good. There's something. Hey, I got something. I got something. 15 minutes in. All right. File password is just a number of yellow stripes on the ankle joint 3D model. Don't forget to rotate it. What the hell is a yellow stripe? 8, 7. Did that look right? No. 8, 6. How many yellow stripes? I don't see any freaking yellow stripes. Yeah, okay, there we go. Can't enable overcharge, so the ankle joint. Okay, our system can do it. It just needs to look at the average strain on each bolt, ignore anything 0 or less. Pin for the circuit breaker room is there. All right. Strain test. These are the bolt numbers. I know, okay. Just needs the average strain for each bolt. Round up. The first one is 45. So filter of this by this is greater than 0. So average. Oh, looks right. Ceiling. First one is 45. Anything 0 or less, round up. The first one's 45. Overcharge the ankle joint until overheat the circuit's fire. Okay, so let's do it. It just needs the average strain for each bolt. Now here, ankle joint, there are 41 of them. There are 40 of these, 1 through 40. So this is 2 is second bolt, right? Yeah. So the second bolt through the 40th bolt. 2, 2. I mean, there's 40 bolts, right? So I'm just going to do like this, right? Okay. Why does this want to give me an error? It's adjacent cells. Yeah, I don't care. All right. To the numbers used for the repair, which I still don't get. All right, the code for the circuit breaker room is 1221. Enter the room by a series of large wires, which probably represent this is the series of on-off switches between different elements, but it's not clear which are on or off. You work through a series of hypotheses for the list of enabled nodes. For each hypothesis, work out the net power being recaptured by summing the power associated with each item. First hypothesis has a result of 34. If you encounter merged cells again, if you encourage merged cells again, you are fired. Yes, that's a reference. The motor XE password is there, which we can do later. But first, let's solve this. Hypothesis P1, P2, P5. P1, P2. These are the ones that are on, right? So that will determine this, right? So equals, so string to array of this, wrap rows 2, then by row concat. This is not the fastest way to do this, but that's fine. I should do a mid with a sequence. By row, concat, whatever. It's already done. So that, right? So now exists. Exists. This is the array to check against, right? It's here. And then we check this, and that'll give me a mask, hopefully, right? So there's the mask, and then it's some product of this and this. Worked out the first one is 34. Something's going to be locked, right? So all these, this is like here, right? But this stuff, these ranges have got to stay locked. That looks like answers to me. And then the password is WC 2024. So let's be doing bonuses as I go here. I have no idea where the hair color is, but I mean, I don't know. Blonde is a hair color, so 1 out of 5 chance. I don't think you do. I'm going to say blue, even though that's not a hair color. That's like an anime hair color. All right, motor, enter the row number of each start cell. How many screw holes does the neural PCB have? Treat a yellowish circle surrounding a blackish center as a screw hole. 1, 2, 3, yeah, 1, well. Like this is a screw hole? What are the screw holes? Wild guess. Let's say this goes here, 8 screw holes. 5 different elements in the 5 different circuits. I can't do these yet. All right. Fully uploaded motor. We think that it's caused by the metal shavings when the motor first starts up, causing problems when they hit the shell. I've identified a series of anomalies below. The shavings fall down when they are created. In the time it takes for each shaving to fall, the motor, the M cells, rotates 90 degrees once. Eventually, the shaving will hit a motor below it. If we can work out the position of the first M cell each shaving makes contacts with, we can solve it. The program is written, we just need the solution. Dim, make contact, send it over. Dim, oh God. All right. T equals 0. Start is R15. Makes the shaving fall a single cell. All right, so as it's falling, all right, so AJ17 is the answer. Enter the row number of each start cell. So let's say it starts in R17. AJ7, right? This is the original one here, right? It moves down. I mean, I can make some guesses on this because, I mean, it's usually going to hit in, I don't know, 17, 18, 20. I guess I could hit like in any of these that are sticking out, right? I'll bet it's going to hit in these like ridges a lot of times, which is what, 4 and 20, depending on which column it's in, right? Like it's either going to hit the one, I don't know. The actual answers. The sum of all the answers. So this you can only do with the answers to everything, which obviously I'm having trouble with. So this I gotta do. All right. So for R17, that means that we're gonna go a certain number down, right? Because we're already in 17 and it's gonna keep going down. No, we're starting in R15. So it's gonna go down 2, right? R17, so arrow trip on this range, starting at this thing, going in the direction arrow down, and stopper is an M, right? So this is the number of there. Why is it not going down at all? So it should go from 17, R7, but we're not starting in R17, we're starting in R15. Right, so if we start in R15, how long is it going to hang out for? It's going to hang out for 2 time, right? So equals the rows of this minus 1. So the rows of that minus 1 is the amount of time that this is going to take, right? So now I've got to do, I'm going to make a version of this where it is addresses, right? How do you do addresses, right? Address, row, column, 4. Paste this, and now I've got the addresses, right? So if it starts here, it's going to go twice, so it's going to rotate twice. All right, so save array of addresses. I mean, I can make like a lookup table, right? How many, the maximum number of times it could fall is 21, right? Less than that, 20. So let's say it could fall 20 times. So at 0, it is ADDR, right? Save array. Now it is load array of this, transform array by the direction arrow clockwise. Okay, and save array again. So if it starts on this, now it's time, the RC start is ref to RC of this as a row. But I need to make this an index, right? So ref to RC of this is a row, the index, but then I have to subtract the start, which is Q2, right? So ref to RC of Q2 of Q2, right, is 217 as a row. So it is this minus this plus 1. Right, because R15 is the, so what is that, 14 of this? Fourteen of this takes you to 15, and then 17 of this sounds like way too much, right? I should be subtracting. Yeah, there we go. 14.2 is correct. New index equals this plus or equals the same. The row is going to get increased by the time, and then the column's going to stay the same, right? So that's my new index. So now the index, so now the board, right, is XLOOKUP of the time on the time returning the rotated board. And then it is the index of that by this and this is a reference of load array of this is AJ7. Okay, well, I mean, who knows if this is right or not, but it's something. Now I'm going to have to go back to level 1, right? Yeah, these all just failed right away, right? Well, I mean, I didn't even really lock anything, right? Arrow trip with this being locked. BG33 is the only thing that's not going to be locked, right? Because that's my input. BG33 is allowed to change. That's got to stay locked. This stuff is not locked. That is not locked. This XLOOKUP stuff is locked. That other stuff is not locked. All right, so now this Is this the correct number? Yeah, 60 to 79. Oh, looks like it fits. Can I do a bonus or is it back to level 1? 5 different element types in the 5 original circuits. Let's create an ordered circuit with 1 element. There are 5 different elements in each of those. This is just like combinatorics, right? 5 different elements in each of the 5 original circuits. How many unique ways are there to create an ordered circuit with 1 element of each type? So 5 to the 5, I think, right? Because it's first time you have 5 choices. The second time you also have 5 choices. So 5 to the 5 is 3125. The key is not provided. You have to work it out through other means. Unknown encrypted data. Okay, well, I mean, I can't use just like freaking the internet on this, right? System root, do not edit. Okay, well, fine. I'll bet I have to edit it, don't I? Unknown encrypted data. Yeah, okay. That's not something I'm going to solve right away now, is it? Oh, I'm still super annoyed that I got stuck on this first level. Text access code for level 6. The sum of the answers for all of these so far. The row number, oh, this is wrong because I'm just supposed to enter the row number. Equals, no, not the row number, equals only numbers. What are the chances that this is actually right? What do you think? Not a lot. It's an interesting idea. Humanity's last stand is 42. Sum of all these numbers. I need to just start guessing numbers, huh? Well, that's too late. This. I mean, I brute force the yellow stripes. Geez, I don't see any yellow stripes. Answer with the key is key, of course. That's always the key. Enter the numbers used for the repair. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those were the numbers that I used. Is trust no one. All right, there we go. That's it for the live attempt. Bye-bye.